all to the new episode of Science Simplified on Bharata First. Through this show, we provide you a platform to let your curiosity out and ask questions related to science and technology, which will be answered by experts. To send us your questions, a form link has been attached in the description box below. Do make use of this opportunity. Now, I would like to introduce to our science expert, Dr. T.V. Venkateshwaran, who is here with us to answer the question sent to us by our viewers last week. Dr. T.V. Venkateshwaran is a senior scientist at Vigyan, Prasar, New Delhi. He is founder-editor of India Science Wire. His area of research includes science, technology, and society. He also writes regular columns on topics related to science and technology. So, the first question for today is:
Hi, Bharata first. Myself, Prince Vir, and I would like you to explain the launch vehicles used by India, mainly PSLV and GSLV. Thank you.
India is one of the very few countries which have developed its own launch vehicle. We colloquially call it as a rocket, okay, but technically it's a launch vehicle. Rocket is one of the engine that is put into this launch vehicles, okay. If you look at the Indian launch vehicle development, it started around 1980s. Okay, I mean, it was called as, in those days, SLV, Satellite Launch Vehicle. Okay, the one which became successful, that which was able to actually complete its mission, was SLV-3. Of course, there were versions like SLV-1 and 2 which failed. So we learned from that failure, and then SLV-3 was made. Okay. So if you look at the SLV-3, its lift-off weight, that is lift-off weight means that its structure and fuel put together was 17 ton. And it was able to take about 40 kilogram to low Earth orbit. What is this low Earth orbit? Low Earth orbit is orbit around Earth, which is around 400 to 600 kilometers from the surface of Earth. Okay, that area, like for example, where the International Space Station is going around Earth, that's called as low Earth orbit. So the SLV-3 was able to take about 40 kilos. Slowly we developed, we produced advanced satellite launch vehicle, ASLV, which was 40 tons, and then it could take 150 kilograms to low Earth orbit. Then we developed PSLV. PSLV was successful in 1994. Okay, this had a lift-off weight of 295 tons, and it could now take 1,600 kilogram to sun synchronous orbit, which is also a low Earth orbit. Okay, around 400 to 600 kilometers. And PSLV has been very successful till now. Although the initial stages we had a lot of trouble, today PSLV is considered as one of the main workhorse of not only ISRO, a fail-proof launch vehicle internationally. Then we started developing a vehicle called as GSLV, Geostationary Launch Vehicle. Okay, what is this geostationary launch vehicle? I mean, this had a lift-off weight of about 450 ton. It was supposed to take about 2,000 kilogram or 2 ton to geo-transfer orbit. Geo-transfer orbit is again an orbit which is elliptical. So when you look at an ellipse, there will be a near point and the farther point, right? At the near point will be around 300 to 600 kilometers. And the farthest point, you can put that orbit in such a way that it will go up to about 35,000 kilometers from the surface of Earth. Okay, which is where the geostationary orbit is. Okay, so you can transfer it to the geostationary. That's the idea, right? So then recently we developed GSLV Mark III, which can put photons into geo transfer orbit. So if you compare these three launch vehicle, the size and so on. So if you compare in terms of, let's say, ambassador car, okay, a PSLV launch vehicle weighs around 245 ambassador car, whereas a GSLV Mark III weighs about 525 ambassadors. Payload. That is how much payload you can actually take to the low Earth orbit. PSLV can take roughly about 2 ambassador cars, but whereas the GSLV Mark III can take about 8 ambassador cars. That's the mass that it can take and put. So that's the launch vehicle. Our launch vehicle technology has been developed systematically. Okay. Initially, we were trying to test the avionics, aerodynamics, propulsion, structure. Then slowly we started developing liquid propulsion, because earlier we were using solid propulsion. Then in the GSLV, we have started using cryogenic technology. So even in terms of fuel, we started from solid propulsion to liquid propulsion to cryogenic technology. Future, we are also looking at technologies like ramjet, scramjet, breathable engines. That's all technology that we are looking at. Future. That's the future, what you can call as a reusable launch vehicle, RLV. Okay. So a vehicle which can take your payload, put it into the space, and then come back and land, which you can again reuse. So which means that you can reduce cost. This technology is also under development. In this technology, in addition to the solid fuel and liquid fuel and cryogenic fuel, we would also be trying a new engine called as ramjet, scramjet. Okay, so these are also some of the things that are being attempted.
Myself, Harshab Singh Yadav, I'm pursuing my chemical engineering from UIT Kanpur. My question is, what is cryptocurrency and how it is produced? And why it is banned in India even after being accepted in countries like in USA? Thank you for considering my question.
Yeah, look at what is currency. Okay, currency is nothing but a token, right? It's a bit of paper, right, today, or a small bit of metal coin. Let's look at a paper. The paper, it is written 2000 rupees. Okay, it's but any of a paper, right? If you look at a metal coin, the value of the metal may not perhaps be equivalent to the value that is inscribed on it. You might say that, well, that is for the convenience sake. If you read the currency note, it is written that to the bearer, the government is promising that it will give 2000 rupees. So that's the, I mean, that's a commitment that a piece of paper is carrying with the signature of governor or finance minister appropriately, right? Yeah. So we might think that, oh, money actually means gold, but we cannot carry gold and walk around. So we are carrying this piece of paper. But then why gold should have some value? So ultimately, if you look at it, the value of currency is actually given by the state, the government. Government is what is giving a value to that. So if a government demonetizes it, then it becomes just a piece of paper, right? So the value of currency actually comes from government. So sometimes economists call this as fiat currency. That is, it's a fiat of the government. Okay, the government can also change the value of that thing. You know, I mean, you can devalue it and so on and so forth, right? So all these things are possible. With the emergence of digital world, people started wondering that can they create digital currency? What is this digital currency? This digital currency is not like, for example, using your internet banking and transferring money from you to your friend or whatever, right? They are still your transaction you are doing through digital means, but it is something very similar to, for example, you are writing a check and giving to your bank, right? So notionally, it's the currency which is actually getting transferred. So a new idea called as cryptocurrency emerged. Today, if you look at, for example, the cryptocurrency, there are many currencies which are circulating around. Most of us would be aware of Bitcoin, okay? But Bitcoin is not the topmost cryptocurrency in the cryptocurrency market today. Ethereum, there are many other Chainlink, okay? There are many other cryptocurrencies which are in circulation. What are they? How are they created? How do they function? The key part of the cryptocurrency is what is called as blockchain. Okay, it's a technology. The blockchain technology is what has made cryptocurrency possible. So, what is this blockchain? That is, suppose if you have a starting block, block number 1, it has something called as hash. Hash is something like, let's say, identifier. Like you have a license plate for a car, right? So in the same way, it's a license plate, or you can say that it's as a hash. Okay, because it's a starting point, the previous hash is 000. Okay, so this hash is created by a system. So when a new block is joined, the previous hash and the new hash are interconnected. Okay, so when a third block is joined, it is interconnected to the previous hash. So there is a chain of blocks by which the transaction is recorded. Okay, so whatever is the latest record, you can go back to the original record, right? This is how the blockchain works. So what do you do? Suppose if you have a cryptocurrency, if you are dealing with cryptocurrency, of course you'll be using a digital medium to transact. Suppose A wants to send money to B. I mean, I'm talking about the crypto money, not let's say Indian rupees or US dollars, not money created by governments, but cryptocurrency. So how does the transaction takes place? Okay. So initially, the person makes a request that I want to transfer. Request meaning that it's a software request. You are not requesting any individual or organization. So your software creates what is called as a block. Okay. So this block is created. That's what is seen as in the online. Like you, there are others who are part of this network, right? All of them are called as peers. Okay. So this information that you want to make such a transaction is transmitted to all the peers, all the parties in the network, irrespective of the number. There may be billion, but all of them are informed. Again, when I say all of them are informed, I'm not talking about person, but their digital system, which may be their mobile phone or computer or server, whatever. Okay, so that is informed. And all of them approve your transaction as valid. Okay, because your block now contains the previous hash and you have created a new hash. These two are checked by all of them, and then all of them say that it's okay. So now your block is added to the previous block. So now a blockchain is created, and this blockchain information is available to everyone. So now this, when the blockchain is created, the money actually moves from A to B. So this is how a cryptocurrency works. So essentially speaking, so when I do a digital transaction in my bank, okay, I send instruction to bank. The ledger is kept at the bank. I may keep a ledger, but that has no sanctity, right? That's only a notes for me. The ledger with sanctity is only in the bank. But whereas here, the ledger with every party who is part of that transaction. That's the whole point. So everyone has the ledger, okay, and that's called the blockchain, okay. So the blockchain idea started around 1998, but it did not pick up, okay. It's only in 2008 it started to pick up. Only in 2009 the first Bitcoin was started. That's one of the first cryptocurrency that has started, okay. Today, for example, the value of a Bitcoin is $19,000. Okay, the Bitcoin started with a value of $1. around 2009. Today, its value is $19,000 in the stock market. Okay. So, what is the difference between a Bitcoin and a fiat money? When I say fiat money, it is Indian rupees or dollars or something like that. Bitcoin, the currency is created by the network, not by any individual. Okay, by a distributed computing. But whereas here the currency is created by a government. And in Bitcoin or cryptocurrency, the governance is by majority rule, meaning that the peers, when they are interacting, 51% has to approve the transaction. That's enough. Okay. Some of them may not be able to approve because of technical reasons, but that's okay. 51% has to approve. Okay. So majority has to approve. But here, the central bank in India, it's a reserve bank. Okay. Which is controlling the creation of money and so on. Okay. And the transaction in cryptocurrency involves only these two people, the person who is transferring the money. I told all the peers are involved, but the peers are not involved consciously, meaning that it's only in their electronic system the checking is taking place. Okay. But whereas whenever that you have to transfer in a fiat currency, you have to do banking. You have to go through a bank. Okay. So there is an intermediate. Okay. And in cryptocurrency, once you have made a transaction, you cannot backtrack. Suppose you have charged to a wrong person. You cannot say that I have transferred to a wrong person, give it back to me. Because there is nobody to whom you can say this. Okay. Once done, done. But whereas in a banking transaction, all those things are possible. Okay. And the time taken in cryptocurrency sometimes is faster compared to, let's say, international banking through SWIFT and other kinds of transfer in international banking. So these are some differences between these two. Okay. When with regard to India, Government of India had initially banned cryptocurrencies, but Supreme Court in 2018 retracted the RBI letter saying that cryptocurrency transactions cannot be banned or need not be banned. So the bank started dealing with cryptocurrency and participating in the crypto exchanges. But recently, the Government of India has brought in a new bill, which is yet to be passed, which is poised to prohibit all private transactions, cryptocurrencies in India. Okay, with certain exceptions. Only state-owned national digital currency. It talks about creating a new national digital currency for India. Only that would be normalized. Okay, and any other possession, issuance, mining, trading, transferring crypto asset would be criminal offense, which can even get you 10-year jail sentence. Meanwhile, there is also a draft national strategy on blockchain, which has been prepared by the Ministry of Electronics and IT. So these are all policies in the making right now with regard to the cryptocurrency and crypto blockchain technology in India. World over, still various governments are thinking over how to deal with this. Because if you let the cryptocurrencies rule, which would essentially means that the financial sovereignty that a country had in the past would be completely eroded. Okay, so this is one big challenge the cryptocurrencies would give to nation states. So the countries around the world are still grappling with how do they deal with this new emerging technology and new emerging currencies.
Hello everyone, my name is Rohit Giri. I'm an UPSC aspirant. We all are seeing tons of requests made through social media about plasma donations. So I want to know what is plasma therapy, how effective it is in boosting immunity, especially related to COVID-19, and when should one donate plasma?
It's a very interesting question because when the COVID first wave struck India and in fact all over the world, one of the earliest therapy that people were considering to provide relief to people who are moderate and severe COVID disease is plasma therapy. Even in India, very swiftly, many of the Indian scientific institutions developed plasma therapy. They started testing it, finding out whether it is actually efficacious. If it is efficacious, then at what stage it is actually helping patient, and so on. Internationally, also a lot of research has gone on. So let's start understanding first how virus infects us, and then how our immunity responds. Okay, so then we'll be able to understand what is plasma, what is there in the plasma, and what is that therapy. Uh, Virus, like say for example, novel coronavirus or SARS-CoV-2, which causes the COVID disease, enters our cell by attaching itself to the something called as a receptor on our cell surface. Particularly, our lungs have this particular receptor called ACE2. So the novel coronavirus is able to infect it very easily. So what does it do? Once it attaches to the receptor, the virus is able to bind inside our cell. Basically, it is able to go inside our cell. In fact, what it does is that it places the viral genome. In case of novel coronavirus, it's RNA inside our cell. Once it goes into our cell thinks that this genome is developed by our cell nucleus and start producing the proteins which are encoded in the genome. So the viral proteins are made. So once the viral proteins are made, what will happen? The viral proteins can come together, form new viruses, and then the new viruses can exit that cell. So basically, if a virus enters one cell in novel coronavirus, in 10 hours, it will produce 1,000 copies of itself. Okay, so basically, novel coronavirus uses our cell as a photocopier and makes copies of itself. So once it makes 1,000 copies, then it can infect cells nearby. That is how our infection becomes severe. Okay, our disease becomes stronger. Okay, all these germs, like a virus, have a structure on their body called as antigen. So antigen is nothing but basically a protein structure. Okay, then to match that antigen, our body produces something called as antibody. So you can imagine the antigen as like a nut. Okay, suppose if you're a car mechanic, okay, a car comes to you, let's say a Maruti van comes to you. So the Bharti engine will have a lot of nuts on its structure, right? In the same way, a virus which is coming to you will have some structures on its body called as antigen. As a mechanic, you will have spanner. With that spanner, you can open the engine, right? So in the same way, our body produces something called as antibody. Right? So this is something that fundamental. But not all nuts are same, right? Some are big, some are small, some are thin, some have six sided, some have more sided. Various combinations are available, right? In the same way, if you're a car mechanic, you will not have one spanner, but you will have multiple spanners. Spanner with different sizes, spanner with different shapes, right? Yeah. Similarly, our body, if suppose instead of a Maruti car, very new car, let's say something that you have never seen. Let's say, for example, a Rolls Royce rolls into your garage. Rolls Royce will have nuts which are very different from Fiat or Ambassador or the cars that you are used to, right? So what do you do if you're a car mechanic? You will tell that person, keep the car here for a few days. Let me go and buy a new spanner fitting to this, and then I'll work on it. Leave it here and go, right? In the same way, when a new virus like coronavirus, to which we are not exposed to, attacks us, our body will not have the appropriate antibody. right? When the Rolls Royce rolls in, most likely the car mechanic is not going to have the correct kind of a spanner with, right? So our body, for example, has 25 billion to billion different T cells. It's one kind of immunity cell which attacks the virus. Okay, so you can imagine it as some kind of spanners. Like a set of spanners are available in a car mechanic. Our body also has it. But for a new virus, we won't have that appropriate one. Okay, so slowly our body will develop the right one. Once it develops, then our T cell will be able to bind the infected cell. Once the T cell is able to bind the infected cell, the T cell will release something called a cytotoxin, which will kill the infected cell. So more T cells will be produced, and these T cells will be attacking all the infected cell. So slowly our infection will come down. So initially the new virus has upper hand, it's increasing in numbers, but slowly our body has developed the right kind of T cell. Like a mechanic goes and gets the correct spanner, so the mechanic can now open the engine, right? So similarly, once our body develops the right kind of T cell, then it multiplies and then attacks all the infected cell. So the disease comes down. In addition, our body also produces another immune cell called as B cell. Okay, already our body will have about 10 billion different B cells. Like a car mechanic has a set of spanners. What is this B cells? B cells produce what is called as antibodies. Okay, they produce and spit out antibodies. These antibodies are having a particular shape. They can go and bind the virus or germ. Okay, so for every specific virus, there are different antibodies. Yeah, antibody that attacks coronavirus, for example, cannot destroy poliovirus. So if you have an antibody for poliovirus, it will be no use when you are attacked by a novel coronavirus. So you have to have the right kind of antibody fitting to that particular germ. Why we have 10 billion virus which are invading us on a daily basis? Okay, many of them may not cause serious disease, but our body produces appropriate B cells and antibodies. So the antibody is usually shaped like this. Why? In the top part of this antibody, it's called variable region. So it's like our key, okay, lock and key. In the bottom portion of the key, where you have the teeth of the key, okay, the teeth shapes are different, right? For every lock, the teeth shape will be different, right? So if you have a blank, you can scrap and then create a new key fitting to a particular lock, right? Similarly, this blank antibodies will slowly convert to fit into the virus that is attacking us. Once that is created, we call as neutralizing antibody is produced, meaning that antibody which is able to attack that particular virus is produced. What does this B cell and T cell do? B cell attack virus outside the cell, for example, in the blood. So antibodies will be rotating in the blood. T cells attack infected cell. So what does it mean? It means in your blood, if you are affected with COVID, B cells are producing antibodies which are against the coronavirus. If you are infected, okay, when you are getting cured. There are various types of antibodies. I am not going into all that. I mean, the most important are IgM and IgG. In the initial part of infection, IgM is produced, and then slowly IgG is produced. Okay, and the IgM remains in your blood only for a very short duration, but whereas IgG is remaining in your blood for longer duration. Okay, so what does it mean? It means that once you are cured, still your blood would be having neutralizing antibody for coronavirus. if you are affected with coronavirus. Once you recover, in your blood, there will be this antibody. So basically, it's like if you're a mechanic and the Rolls-Royce has come into your mechanic shed, you will have the necessary tools for the Rolls-Royce. Okay. So what do? From the recovered person, if you take the blood and separate out the serum, the antibodies will be there. Okay. Plasma, the antibodies will be there. So if I transfer this plasma to somebody who is suffering from COVID, let's say severe COVID, the person still has not developed the antibody in his own body or her own body. But because we are giving something from external, still that would be able to fight with the virus and reduce the effect of the virus. That is, reduce the severity of the disease. That's the idea. That's how the plasma therapy was started in COVID. For example, plasma therapy is not done only in COVID. It is done in very many cases. Okay, many different kinds of diseases related to immunity. Plasma therapy is carried out. In some, it's very effective. In some, it's not very effective. With regard to COVID, the current consensus is it's not greatly helpful. It may be helpful for a few people, maybe at the initial level, but it is not life-saving. Meaning that if you are not, if you are in a serious condition, plasma therapy is not going to help you so much. Okay, that's the international research consensus. Although in some people still the plasma is useful, so that's why you find that people are asking for plasma and trying it out. Okay, so when you are in a moderate situation, plasma perhaps helps you in fighting the disease before your immune system is able to produce the right kind of antibodies.
Hello sir, this is Antigen and I want to ask that what is gravitational force and what are the forces that keep our solar system intact, and what are the similarities and differences between the forces that play a key role in an atom and our solar system?
Yeah, very interesting question, because gravity, although is one of the forces that we knew from the earliest times of human civilization, is still a big mystery. Okay, we don't know so much about it. Let me start with this clarification. Gravitational force, okay, or gravitation, is force of attraction between any two bodies in the universe having mass. Gravity is the gravitational pull, okay, of Earth, of objects near to the Earth. Okay, so this is how technically we use. Initially, we knew gravity, then we came to understand gravitation. So we are using the same terminology there. That's it. If you look at the Newtonian understanding of gravity, which we would have studied in school, let's say there are two objects, object 1 and object 2, with some mass m1 and m2. Okay, so the force between these two objects, okay, object 2 will attract object 1, object 1 will attract object 2. Both will be attracting each other, but the attractive force, okay, which is F1 equal to F2, which is equal to F, is G into M1, M2 by D square. D square is the distance between these two objects. Something that we would have studied in our school. If you try to recall, you can easily recall. Okay. So basically, under Newtonian theory, the gravitational force depend on the mass. If the mass is low, then the force between them is low. If the mass is high, the force between them is high. Second, distance. If they are closer, the attractive force is more. But if they are farther apart, the attractive force is less, because 1 by d square, right? So that's something that Newton's theory tells us. Okay, so basically using this, that if you know, for example, two objects mass, the distance between them, you can actually calculate the force that is there between these two objects. if you look at the modern physics, today we know that there are 4 fundamental forces according to our known modern physics. First, of course, is gravitation. Second force is what is called as electromagnetism. Okay, something that we see in our daily life as electricity or magnetism actually is only same force appearing in 2 different dimensions. Okay, so together we call them as electromagnetism. Then there are 2 forces which are active at atomic size. Okay, we don't normally see them in our everyday life. Okay, we don't realize them in everyday life, like electricity or magnetism or gravitation. We don't feel it in our everyday life. They are called as strong force and weak force. What is this strong force? Look at a nucleus. Inside that nucleus, for example, there are more than 1 proton. Proton is positively charged. We know that 1 proton should repel other proton. So if these 2 protons are repelling, then these 2 protons should be going away from each other, right? So then the atomic nucleus should split, but it's not happening. There is some other force which is acting against the repulsive force between protons and keeping them together. That attractive force, which is keeping the nucleus together, is what is called as strong force. Okay, that's called as strong force. And again, in our school physics, we would have studied something called as natural radioactivity. Okay, in the natural radioactivity, sometimes what happens is that a neutron, that is neutron, a particle having no electrical charge, emits an electron and becomes a proton. Okay, so it is emitting 1 electron and it is becoming proton. So both put together, the electrical charge is neutralized, but neutron has now become a proton. Okay, and by emitting an electron. This is happening through a force called as weak force. Okay, that's a name that we have given. We call it as a weak force because the forces are acting only when the particles are sufficiently far away, not when they are very near. Okay, strong force occurs when they are very, very close to each other. Okay, and the force of this weak force is really low compared to others, so we call it as a weak force. Okay, so these are the fundamental 4 forces which are acting in our universe. So as you can very clearly see, if you are looking at inside an atom, 3 forces are very important. Strong force inside the nucleus, weak force, nucleus and the electron, electromagnetism in terms of nucleus and electron. Okay, all these 3 forces are something that you can easily find inside the atom. The forces are strong force, electromagnetic, gravitational, weak. Okay, they also act through certain particles. Okay, that's the modern understanding. So, for example, strong force act through a particle called gluon. Electromagnetism act through a particle called photon. We all have heard of that, right? Particle of light, that is photon. Similarly, weak force as W boson and Z boson. Okay, gravity, there is a thought that there is a particle called graviton, but we have not found. So that's why I was saying that gravity is still not a completely solved force. There are a lot of mystery in gravity. Maybe only future research will tell us a lot about it.
Jai Hind sir, my name is Rohit. I am a UPSC aspirant. My question is regarding gravitational waves. What are these and what are their significance in understanding the phenomena like black hole and dark matter?
Gravitational waves became a buzzword a few years ago when actually it was discovered. It was proposed by Einstein about 100 years ago. Okay, he said that there should be something called black hole, but it was not found during his time. In fact, he even wrote that most likely we may able to never discover, we may able to never identify this gravitational wave because it is so weak. Okay, it is so small that it will be very, very difficult to detect it. But 100 years, we were able to detect it. So let's understand the difference between the idea of gravity under the Newton physics and the idea of gravity under Einstein's relativity. Okay. In Newton physics, the gravity is the force pulling objects together. It's a force of attraction. Okay. It depends on the mass of these two objects and the distance between these two objects and a gravitational constant. Once again. So under Newton, the force of gravity is a force of attraction, pulling objects together, okay, which depends on the mass of these two objects, the distance between them, and so on. In the concept of Einstein's relativity, the gravity changes its notion completely. It is no longer a force. In Newton's physics, it's a force. But whereas in Einstein's space-time idea of relativity, gravity is not a force. Gravity is the curvature of the space-time. I'm using some technical term. You might be a bit confused of what it is. So for people who are not very familiar with physics, let me use an example or an analogy. Okay. Let's say you go to a playground. There are these slides, right, where children sit and then slide down. Okay. So you have different slides. A slide with steep sliding, some slide with not so steep sliding. What will happen? Depending on where you are sitting, the way you will come down will vary, right? If the steep is very sharp, you will come down very fast, right? In the same way, what Einstein said is that you imagine the space-time as like a blanket. Okay. 4 people are holding the 4 sides of the blanket. You place a iron ball somewhere in the blanket. So wherever you place the iron ball, you will find a depression, right, in the blanket, right? So imagine that blanket as a space-time. Now this mass has created a curvature in the space. So if you put a marble, the marble will roll down to that iron ball. Okay, it's rolling down because the space itself is curved, right? So that's how Einstein explained the space-time curvature. I'm telling you in a very simple fashion. Okay. So, like for example, if you put a stone in a water, it can create ripples. Okay. Any disturbance of this space-time can create wave, right? Okay, so that's called a gravitational wave. So like this, for example, as you can see, that if object is moving in a space-time, okay, a moving object, an accelerating object in a space-time would create ripples in the space-time. Okay, that ripples will travel as gravitational wave. Okay, and normally, even when, for example, if you are walking on the road, you are creating gravitational wave. But that gravitational wave will be so small that it is not possible to detect today. Maybe tomorrow possible, but today it's not possible. Today, if there are 2 black holes and they are going around each other, they will also create ripples in the space, okay, in the space-time. That will come as gravitational wave. That we are able to detect. If the objects are so massive like a black hole, then the gravitational wave created by that we are able to detect today. We have built a detector system like LIGO. Even in India, one of the LIGO center is going to be established. So this LIGO is like L shape. Okay, it's exactly L shape, 90 degrees in between. So when the space wave, space-time wave, gravity wave is flowing and then creating a ripple in the space-time. When the ripple is passing through this object, The way, for example, one arm of this LIGO will contract and expand, okay, will be different from the way, for example, the other arm will be contracting and expanding. Using this difference, you are finding out whether we are passing through a gravitational wave or not. Very simple. On a water, if there is a wave, okay, if you put a small cork, the cork will go up and down, right? So from the moment of this cork going up and down, you can find out whether there is a wave or not, right? Even if the wave is not visible to your eye. Same way, this LIGO detector will also wobble. Okay, that is what you are detecting. That's how we are catching this gravitational wave. So why it is important? I mean, see, in astronomy, you cannot really go to astronomical objects. Okay, we have gone to moon, we have landed on Mars, but we have not even gone to the nearest star, right? It's not going to be easy, right? So we have to do research from sitting on Earth. So you have to do research from whatever that is emanating from those stellar objects coming and reaching Earth. One thing that reaches our Earth is light, electromagnetism. We are using it, telescopes, radio telescopes. We are using various forms to study the universe. Massive objects, like for example, black hole, also emit gravitational wave. So if I study the gravitational wave, like I look at sky through a telescope, I see stars which I cannot see through my naked eye. Maybe I'll see a new vision about universe. So it is going to give us a third eye to look at the universe. Beyond light, you are going to have a new kind of way to look at the universe, that is a gravitational wave. That's why the gravitational wave observatories are being established in many parts of the world. And of course, it's an international collaboration, only then you can do it actually. So once more such LIGO centers are created, then we will be able to do actually gravitational wave astronomy. So when you do gravitational wave astronomy, many puzzles that we have about our universe, like dark matter, black holes, and so on and so forth, we will be able to study even deeper. That's the hope that one has about the gravitation.
Thank you, sir, for your insightful explanation of the questions. On this note, it's a wrap up of today's episode of Science Simplified only on Bharata First. Be scientific, be inquisitive. Please like, share, and subscribe to Bharata First for such amazing content. See you soon.